All right, this is lesson 9 in the probability and statistics unit, compound probability. The homework that goes with this is page 21 and 22. All right, yesterday we talked about experimental and theoretical probability. And it's experimental if it's based on something that you've done, and it's theoretical if it's just based on the number of outcomes. Today we are talking about two different kinds of probability. It's dependent and independent. Independent means one event does not affect the other. Dependent means one does affect the other. And you'll see what I mean when I go through a couple of examples here. All right. Independent events. A spinner and a dice. They have nothing to do with each other. We can do an example. We could do getting an A on a test and the probability of winning a lottery. They don't have anything to do with each other, so they are independent. Describe it. One does not affect the other. One does not affect the other. All right, now, this is important. Probability, when you have multiple events, when you have a probability of an A and then a B, all you do is multiply the events. So, let's look at this. This is what we call a tree diagram. You're not going to do this all the time, but we are going to do it for this first example. So, it says, one letter tile is selected, and the spinner is spun. Fill in and use the tree diagram to help you determine the sample space for the different outcomes. Well, the first thing that we do, we grab a tile, and the tiles are G, B, E, or A. Now, once we do that, and we spin our spinner, if I get a G, I can get an A, a B, or a C. So, for this first event, I can get a G and then an A, G and then a B, a G and then a C. For the second, I could get an A, B, C, I could get an A, B, C, I could get an A, B, C. Now, let's list all of our outcomes. This will be a B with an A B with a B, a B with a C. An E with an A, an E with a B, an E with a C, and an A with an A, an A with a B, and an A with a C. So, that is our sample space. And then it says, what is the probability that both will be a vowel? Well, vowels are A, E, I, O, or U. So here's two vowels. Here's two vowels. So probability of both vowels will be 2 out of 12, which is 1/6. Now, that is one way to do it. I would never do it that way. Watch this. Probability of getting a vowel on the first times probability of getting a vowel on the second. What's the probability of getting a vowel on the tile? Well, it's 1 out of 4. What's the probability of getting a vowel here? 1 out of 3. When I multiply, I get, I lied. This is 2 out of 4. So I'll get 2 12, which is 1/6. So, you can draw a tree diagram, have the entire sample space, and then look at your outcomes, or you can just take the two independent outcomes and multiply them. And this is independent. The tile does not affect the spinner, so it is independent. All right. Draw a tree diagram to check your answer. So we're going to do the dice and then the color. Now, I'm going to look at this. If I started to draw a tree diagram, and I'm not taking the whole time to do this, I would do 1, 2, 3, 4, 5, 6. Then, off of each one of these, I've got 1, 2, 3, 1, 2, 3, 4, 5. I would have red, purple, blue, yellow, green. So, I'd have a 1 and a red, a 2 and a 1 and a purple, a 1 and a blue, a 1 and a yellow, a 1 and a green. I could continue on, and I would have a 2 and a red, and a 2 and a purple, and a 2 and a blue, and a 2 and we could go on and on. Wouldn't there be 36 outcomes? So, what is the probability probability of not spinning a blue and then rolling a 3 or a 4. So we're going to have 36 outcomes. I would never do this with a tree diagram. Watch how easy this is just using probability. Probability of getting a 3 or a 4 times probability that it is not blue. Well, the probability of getting a 3 or a 4 is 2 out of 6 times. What's the probability that it's not blue? Well, I've got 4 out of 5 are not blue. When I multiply this, I will get 4 out of 15. Dependent. When one event does affect the other. Now, example 3. There are 4 oranges, 7 pears, 5 apples, and a fruit basket. Ignacio selects a piece of fruit at random. He holds on to it. And then Terrence selects a piece of fruit at random. Find the probability that 2 apples are turned. So we want the probability of an apple times probability of an apple. Well, when the first guy picks, there are 5 apples out of 11, 16 pieces of fruit. Times. Now, Ignacio took that apple and it's gone. What is the probability that Terrence gets an apple? Aren't there now only 4 apples left? And there's only 15 pieces of fruit. And when you multiply that, you end up with 112. This is called dependent because what happens in the first event affects the second one. The second one is dependent on the first one. Independent, they do not affect each other. Dependent, they do. But in both cases, you find the probability the same by multiplying. Okay, we're doing the same thing, but finding the probability of an orange and then an apple. So I'm going to go back to here. Probability of an orange, and then